Hello there, Algebra students. This is Mr. Kashi speaking. With this video, what we're going to do is we're going to go through our first section of Chapter 10. And this is basically just an introductory section talking about what quadratics and what quadratics graphs are. Here we're going to be talking about a quadratic equation. And the first type of equation that we're going to be studying is what we call standard form. And standard form is simply y equals ax squared plus bx plus c. And obviously when we have an equation, the a, the b, and the c are actually going to be numbers. And that's how we have many different, you have an infinite amount of different equations that you can come up with. Just as just to review, there's three different things that we're going to be talking about. We have equations, which is just generally ax squared plus bx plus c. But we're also going to be talking about tables, and we're going to talk about what they're called t-charts. So you have x and y, and you're going to be filling those in, and then we have graphs, and the graph of a quadratic is called a parabola, and a parabola is going to look something like this. Throughout the chapter, we're going to be starting in one and going to another, and so all of these are interrelated. So if we start with the table, you should be able to come up with an equation and a graph. If you were to start with an equation, you should be able to make a table and a graph, and so on and so forth. So that is the overview of what we're doing in Chapter 10. So first we want to talk about the parent function. So parent function is the simplest equation that we can think of. And for quadratics, that's going to be y equals x squared. So we don't have a b term. There's no plus bx or plus c. It's just y equals x squared. And the easiest way to graph that is to create a table first. And so what we're going to do is, this is our t-chart, but I prefer putting the equation or the expression in the middle there. And so what I would do is I would start with -2, -1, 0, 1, and 2. We're going to plug in those 5 numbers for our x. And as we do that, we'll find out what our y's are, and then we'll be able to plot our points. So here we're going to plug in -2 squared. That would be -2 times -2. That would be 4. And here, -1 squared. That would be -1 times -1, which is a +1. Here we have 0 squared, which is just 0. And 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. So then what we can do is we go over here to the graph, and we're going to plot these points. So I'm going to start at -2, 4. Put a point right there. -1, 1. 0, 0. 1, 1. 2, 4. And then what we do is we connect these dots. Even if you wanted to go out a little bit further, we could go -3. -3 squared would be 9, so you can put points up there. Okay. And then we have this curve that it's not a straight line. It comes down and it curves and it touches the x-axis once. It comes up here. And then we have arrowheads at the end of each here, because those go on forever vertically. So that is the parent function. So that's what a parabola is. It is the graph of a quadratic equation. It's not a straight line. And we're going to be, just like we did with lines, we're going to be taking these parabolas and creating different equations so they look differently on the graph. And we're going to talk about those characteristics later on. So here is a parabola. And we're just going to talk about the different parts of the parabola. First thing is what we're going to talk about is what we call x-intercepts. X-intercepts are right here. In this case, it's -3 and 1. They're not always going to be those numbers. Okay. And this is x-intercepts are where the parabola crosses the x-axis. Okay, in this case, it's going to cross it in 2 different points. The next term that we're going to talk about is the y-intercept. Well, the y-intercept is right here, where this is where the graph crosses, the parabola crosses the y-axis. Where parabola crosses the y-axis. So that's only going to be in one spot. In this case, it's -3. It's obviously not always going to be in -3. And then the last thing for a parabola is what we call the vertex. And the vertex is this point right here. And that is defined as the minimum or maximum point on a parabola. So if the parabola was pointing down, it would be a maximum point. In this case, it's a minimum point because it is the lowest point on the parabola. So we'll just go through a few examples on vertices. Okay, so if it's one vertex that you're talking about, you call it a vertex. If it's multiple, you call it vertices. Okay, and really it's just the point that where the maximum or minimum is. And so here you're always going to have a point, ordered pair x and y. And in this case, for this, we would say the vertex is at 1, -2. And it is a minimum. So we'd put min right next to it. And for this parabola over here, we'd have a maximum. And that would be at -2. And we go up to 3 there. So we have -2, 3, and we have max. Go ahead and pause the video and do these two next. I will be going through them in, here in just a few seconds. But pause the video, give these two a try on your own. Alright, so the vertex of these two, here we would have, I know the grid kind of gets blanked out there, but we would have 4, 3, and that would be a max. And then here, on the one on the right, this would be the coordinate -3, -3, and that would be a minimum since it is the bottom point of the parabola. So this is the first 4 slides of notes today, and they were just going through some notes on the parts of the parabola and how to find the vertex. Stay tuned for the next video that goes through graphing some different quadratics.